روبروی غرفه شرکت تورلبز هستیم و شرکت تورلبز در واقع محصولات که توی چین عرضه میکنه رو آورده توی این نمایشگاه. و این هم می‌بینیم که یک تایم تگر هست که اینجا نصب کردن. Hi. Excuse me sir, I have a few questions about this optical taper. Actually, as I see here, you are using time tagger.
Yeah.
It seems to me that you are using single photon detectors or quantum technologies, right?
Yeah, these three are single photon detectors.
All right, and actually you are it seems to me that you are generating
Photon pairs.
Photon pairs, entangled photons, right? And this demo actually is presenting different parts of the measurement setup, right?
Yeah.
All right.
Based on the photon pairs from the BBO crystal.
BBO crystal, all right.
Yeah.
All right, that's okay. And what is the price, the final price of this quantum kit?
The whole price in RMB, the Chinese is
No, that in RMB, right?
300k.
300k RMB. That's 600,000 yuan. Divided by 7, all right?
Yeah.
In dollars. Yeah, that's okay.
Right. It depends if you buy it from the US or from Germany, it's like 30,000.
Yeah, I know. But in China, it's 300k, right? All right. And I want to know about the accuracy of this time tagger. What's the range of accuracy?
So the original time tagger 20, I think it's like 20 picoseconds.
20 is the accuracy, right?
As in the jitter.
All right, jitter, right.
But
Is it possible to use maybe cesium or rubidium, I mean optical clocks or atomic clocks to enhance the accuracy of this system?
I don't know.
Because it seems to me that one part of this actually inaccuracy is due to the timing, right?
Yeah, but
And
for this
using
teaching kit, actually we have a version with like 700 picoseconds jitter because we don't care. We
All
just
right.
want a cheaper one. And
It seems to me that we can use quantum technology to enhance the capabilities of measurement systems for
Probably,
measuring.
yeah.
Yeah.
But this is just for teaching. So.
All right. It's just
Yeah.
for teaching. Yeah. All right. All right. And please let me know other products that you have in the field of quantum technology.
Yeah.
Do you have other setups or other systems?
So we have basically an off-the-shelf single photon.
All right.
So here you get your.
It's single photon based on SPDs. All right. Yeah. Actually, you are creating correlated photons, right?
Yes.
And by blocking one
Yes.
way. Yeah.
Yes.
All right. And what is the rate of generation of photons? This system.
I would look it up. Or it's here, like there's a 450.
All right. Yeah. 450 kilometers. All right.
It's fiber
And-
coupled, so you get them out.
What is the output wavelength of photons?
This one is 810, I think.
All right. And do you have 15 nanometer for?
I think that is in development.
All right. All right. But there are competitors in the market that are ahead of Thorlabs in this field. Why?
I don't know. Somebody decided to make it.
All right.
It's about my agree.
That's
I think we're trying to get more into the quantum market.
All right. And please let me know about MEMS pixel. What does it mean? Are you using MEMS technology in vertical cavity surface emitting laser?
Something like this, yeah, and you get a swept source out. So you have like one 1060 to
All right.
4000,
It's
you
actually
can swap.
all right. It's actually an external cavity. All right, for actually adjusting the output wavelengths on the laser, right?
Something like this, yeah.
All right. And what's the resolution actually? What's the resolution of tuning the output wavelengths?
That is a very good question.
All right.
Let me look it up. Maybe it's on the webpage.
All right.
So that's not my product.
All right.
It's actually a byproduct of the OCT. So they needed this swapped source for the OCT, and then they made it a
بله اینم لیزر وکسل ممز هست که از حدود 1060 نانومتر کار میکنه. این هم که دیدیم منبع تک فوتون بود، نرخ 450 کیلوهرتز تولید میکنه به صورت هرالدد هست در واقع. و این هم مالتی چنل فایبر کاپل لیزر سورس هست، یک منبع لیزری با فیبر کوب شده چند کاناله. اینجا میبینید در واقع 4 کانال داره. چهار کانال هست. بله خیلی جالبه. It's actually a new product, right? This one, multi-channel fiber coupled laser source.
This one is newish. This one is completely new.
All right. What's the price of this one and this one?
For the MEMS pixel, I can tell you. Prices. It's about the same as the quantum kit. Actually, it's like $30,000.
$30,000? Which one?
The MEMS pixel.
All right. $30,000. All right.
And the other one, what's the part number? MCLS.
All right. Ben می‌بینیم لیزر فایبر کاپل هست.
I think this one is. This one is actually custom, so you choose which wavelengths you want to have inside, and then you get a custom price for the thing.
And who are the potential customer of this laser? Maybe they are using quantum technology because, for example, in laser cooling, we need different lasers. All right, we need, for example, stable laser to have actually. In 3-axis confinement.
Yeah.
Right.
I think any setup where you need to synchronize 2 or more lasers.
Of course, yeah.
You want to have one controller for them all, so you
can.
You have one internal trigger and
all right. So the benefit of this system is that you have one controller for all these 4 lasers.
Yeah,
all right.
Yeah, that's the idea.
It's amazing. It's a compact, actually, solution for that setup. All right. That's all, actually. And what is that? Ultra
low noise.
What is this?
It's a laser controller with the actual laser for just like having as low noise as possible in the output power, like the most stable power you can.
Stable means you mean actually output power,
wavelength
right?
stable and output power stable. Yeah.
How does it control the output wavelengths actually? By controlling the temperature?
Yes, that's
all right. Yeah. So by controlling the exact and accurate controlling of the temperature, you can actually adjust the output wavelengths, and by controlling the injection, actually the current. All right, that's okay. All right. I'm familiar with this system. What's the minimum power that we can measure with this system? Is it possible to measure few photons or so? How many photons? What's the minimum number of photons that we can measure?
That's a good question. The minimum power I probably can figure out, but the minimum number of photons then I would have to calculate. But
thank you. Is a range of maybe 10 to watts or so?
10 to watts seems low actually.
Yeah.
I think picowatt seems kind
really
of
high.
doable, but yeah.
Thousands of photons.
Yeah.
Right?
So I'm not. Yeah.
It's actually for the demo.
I mean the specs are on the webpage.
All right.
You only need the part numbers, and then you will get all the specs.
All right.
Figure.
And would you please explain the details of this system?
Yeah, that's an OCT, optical coherence tomography.
All right.
So it's basically what your ophthalmologist or the eye doctor uses.
All right.
When they want to look in your eye. So it works. It's basically based on an interferometer, and you move one arm of the interferometer, and you can basically, by interference from different layers from your sample, you can look into the depth of the sample.
All right. What depths? What's the maximum depth that you can look at?
It depends. Really depends on the system. So it can get. For the eye, you need.
All right. So it has potential application in biomedical, medicine, and
but also
and biological
quality
systems.
control. If you want to find some micro damages in your system in the depth, in some few millimeters depth or something.
And what's the best resolution that we can have from such a system?
I'm not. So you have to check the webpage.
All right, that's okay. All right, that's okay.
So laterally, it's just a microscope. It's a lateral resolution.
Yeah,
microscope resolution. In depth, you can get really, really good resolution. And this one's a birefringent microscope. So you use some materials have the effect that they rotate polarization or make it elliptical or whatever.
All right.
And this basically a microscope that also detects polarization.
All right. All right.
So here we have some plant leaf in there, and it seems like some of the cells in this leaf have this birefringent property, so you can see them really line up in the microscope.
All right. All right. This is amazing. That's amazing. All right. Thank you very much. Thank you for your time. Thanks.